Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aleef Eqmal bin Muhammad Khairudin. Today, I'm going to present my project, which is the investigation of three-phase Y-connected generator. First thing, we go to introduction. We are given a task to investigate or analyze the electrical system that consists of a three-phase Y-connected generator, transmission loss, and a load with acceptance power factor lagging. We also know that three-phase alternating current electrical energy is generated by three-phase generators and transmitted over three-phase circuit system and wiring. Three-phase electric power is a common method of alternating current electric power generation, transmission, and distribution. We also need to evaluate and analyze the active power absorbed by the loads by using 2-watt meter method and the conventional measuring method. Second one, we're going to objective of our project. The first one is to investigate the three-phase Y-connected generator. Second one, we need to make sure that students know about the Malaysia standard electricity supply. And the third one, we need to study and evaluate the active power absorbed by the loads by using 2-watt meter method and the conventional measuring method. The third one is methodology. Here is the methodology that I use for my project. The first one is project assigned by the lecturers, and the second one, find all the parameter and construct the Y to Y circuit. And the third one, draw a simulation on PSIM. And the fourth one, get all the calculated result with PSIM simulation and compare. The fifth one, did a discussion with the results achieved, justify the standard operating, and did a conclusion on the project. The last one, submit the report to be evaluated by the lecturers. Next, we're going to take a look at result and calculation. Here are the result and calculation that I have obtained by in my project. First one, we need to find V phase by using formula, which is V line to line divided by Z3. The value of V line to line is given to the students by the lecturers. The value that I obtained is 132 kilovolt. Then I calculate by using the formula and I obtain the value of V phase is 76.21 kilovolt. In the circuits, the value of Z, which is load, is obtained by using our metric number. Next, we need to calculate the value of current between line by using formula, which is voltage divided by Z load plus Z line. For each load, which is IEN, IBN, and ICN. The value of IEN I obtained is 484.16 ampere with angle negative 7.667, while the IBN is 484.16 ampere with angle negative 127.667, and the last one ICN, which is 484.16 ampere with angle 112.3 ampere. In the Y-Y connection, the value of I line is equal to I phase. Therefore, the value of I phase A, I phase B, I phase C is equals to the one that we calculate at the I line. Next, we need to calculate the V phase for each load. For example, here, V phase load A by using formula I phase A minus load A, and I obtain the result is 39.45 kilovolt. Next, after we obtain the phase voltage, we can find the value of voltage drop. The value of voltage drop can be calculated by using formula, which is V supply minus by V loads, and divide by V supply, and then we times with 100% because we need the answer in percentage, and the voltage drop that I obtained is 48.22%. After that, we need to find the VLL for each load by using formula. Set 3 times with V phase load A. For example, for load A, the value that I get is 68.343 kilovolt. For the wattmeter method, based on ESA P3 for the F value power factor lagging 0.9 for voltage 130 kilovolt and above. Therefore, when the value is 25.8419, power measured by the first wattmeter is calculated by using formula VL time with IL time with cos 30 minus 25.8419, and the value for first wattmeter is 3.3002 times 10 to the power of 7 watt. The power measured by second wattmeter by using the same formula, but this time the cos 30 plus with 25.8419, and the value of second wattmeter that I obtained is 1.8579 times 10 power of 7 watt. Therefore, we can find the total power, which is by using formula P1 plus with P2. And the value of the total power that I obtained is 5.158 times 10 to the power of 7 watt. For the conventional method, the real power consumed by the load is by using this formula, which is P load equals to 3 times with V phase L times with I phase L cos phase, and the value I obtained is 5.696 times the power of 7 watt. The picture below shows that the value that I obtained by using the P-sim. As you can see here, the value is also 5 point something, and the value is slightly different from the P load that I have calculated by using the formula. Now we're going to take a look at discussion and conclusions. Okay, for discussion, there is a slightly different in calculated and measured value for all parameters that I have calculated before. We also know that line current and phase current has the same value, but not for the line voltage and phase voltage. For conclusions, the objective of my project has been achieved, which is the students get so much knowledge about the Malaysia standard electricity supply. Second one, student also be able to understand about three-phase Y connected generator. The third one, the three-phase connected Y generation has been analyzed. And the last one, student also be able to evaluate and the active power absorbed by the loads by using 2-watt meter method and the conventional measuring methods. That's all from me, Muhammad Aleef Eqmal with Muhammad Khairudin. Thank you.